All right, so in the last 20 years, we're going to look at some of the current active license holders in the United States for the 902 to 928 band. So in the amateur radio world, we probably know these codes that are associated with our licenses. So as a new license holder, you are known as an H8 class. And then if you change your call sign to a vanity call sign, so this is something that was not sequentially assigned, it's a specific call sign that was requested, those are known as HV or vanity service. So there's so many other different classifications. And so if we look at the left, these are three that are the only three type of licenses that come up by searching the FCC database in the 902 to 928 spectrum. So we have CN, which equals PCS narrowband, LN, which is 902 to 928 location narrowband using non-multilateration. And that's a fun topic. That's a whole separate conversation on radio direction finding. So not included here. Then we have location and monitoring services, which do use multilateration. So there's a big difference between how those two services work. And that's really what we know as CN, LN, and LS. And so now if we start to look at some details here, here we have a company called Progeny. They have some spectrum within the 902 to 928. You could look at 921.75 to 25 and a little bit higher up in the band. So they're known as using FCC service LS, and they currently have 78 licenses of the total 650 license holders. Matter of fact, of these ones that we see here on the screen, these are the top 20 license holders. And so of the 650, 516 of them are actually held by just these 20 companies. And that represents almost 80%. And so here's a bunch of organizations that, do have some special characteristics for what they're actually using devices for. So again, these are the license holders. These are not the companies that manufacture equipment. These are organizations that utilize it and have requested specific frequencies to use on these frequencies. And so then we have another example here with a company called Space Data Radio. They're outside of the 902 to 928 spectrum. They actually got triggered because when I ran the search, I did 902 to 928. So that's exactly why Space Data Radio came up. But I still think that it's really important to show this, that we have two different examples here. We have one company that is commercial that wanted to utilize their services within this multi-user spectrum. And then we have another company like Space Data Radio who said, we don't necessarily want to potentially have interference or create interference for others. And so they opted to get spectrum just outside of this chunk. And then there's another few license holders that just have 2 licenses each. But again, the point here is there's 3 major users of license services in this spectrum. And so when we move beyond these 2 examples, we look at all these others, and they actually hold services in the LN type of service. And so there's over 50 frequencies, the best that I can tell by looking and examining at all of these licenses. And if you notice a trend on the left-hand side of the screen, most of these other license holders all tend to be in the rail or intermodal or the logistics category. So they have specific frequencies to use in their parts of the United States. So there might be some common, but maybe some different frequencies. If you're in Texas versus North Texas versus Central Florida or Washington State, or even here in New York in the Albany area, there's lots of different license holders. So again, very important to point these out. These are licensed devices by license holders. These are not necessarily directly governed by Part 97 and Part 95 and Part 18. And we all have to deal with this interference for anything that we may be using as consumers, and commercial users also have to be aware what could potentially be creating impact for them from other unlicensed users. So again, I'll apologize in advance for this overly busy and overly colorful chart, but what I really wanted to try to show here is on a per megahertz basis, 902, 903, 904, etc. What can we typically see? And so what I started to model here was looking at where do we have random ISM devices. So these are all consumer devices, could be a dog tracking collar, could be something for checking water levels or penetration on a boat, utility meters, water meters, intercoms, mailbox alerts, anything. So there's all these random ISM devices, which we saw those were that 25,000 different devices that have been manufactured by various manufacturers. Then we have the things that are licensed, and then we have things that are using licensed equipment on specific channels, and we'll talk about something like the Things Network a little bit later, as well as Meshtastic. And then we have other things here. So you'll take away that between 902 to 906, there's a lot going on between a lot of people. There's amateur radio activity, there's rail activity, there's older cordless phones and stuff, there's all these other random devices. And then most importantly, and what really drove the reason for this presentation, is some recent news from a company named NextNav, and they're proposing to have about 15 megahertz of total spectrum across this band, and it's creating quite a lot of havoc and anxiety, not only within the amateur radio community, but also within the rest of the commercial world. And so that's really what drove this reason for having the presentation. So again, as you kind of look at this slide, as we get into like the 909, 910, 911, it seems like it's less busy. And actually, a couple of years ago, and I'll come back and talk about this later in the presentation, myself and a few friends, we started to look at this and said, you know what, if we're going to experiment as amateurs, we want to find a nice quiet spot. And so we started to gravitate some of our own experimentation as licensed amateur radio operators on a secondary spectrum basis. We chose to experiment around the 911.25 area. And I'll explain a little bit more about that later on. So here we'll just kind of start wrapping things up on the commercial side before we start talking specific to amateurs. Here's an example for organizations that have specific licenses specifically at 915.00. And so many organizations will refer to the 902 to 928 band as 915. That doesn't necessarily mean that everything's using 915, but believe it or not, there are license holders, and we can see some examples over at left. These are just in the last 2 years. So from September of 2022 to present, there's over 300 license holders just in the last 2 years. It's actually quite more if we go back 20 or 40 years. But for the most part, I feel like just 2 years to show that there's 300 new or recently renewed license holders shows that this is in demand by the commercial world. And so I'm not going to let this video play all the way through. I mainly use this for the live presentation. But if anyone's ever kind of wondered what exactly are railroads using the spectrum for, I found this video from a commercial company named TransCore. They are a very well-known and reputable vendor of equipment used by the rail infrastructure. And as we can see through the video, we see a train passing through with different flags. This is an international standard now. They take their transponders, they attach them to rail cars. So there's over 1.6 million rail cars, again, as a reminder, in the US. These are transponders, so these are devices that they attach to a rail car. And as we see, once it goes past an infrastructure, it scans it, and it is able to read the information that's been encoded on that transponder. And so this is really helpful information because it gives details on what's the cargo, what's the weight, where its destination is, and it routes it up to the cloud. Then we also have an example where maybe there's a maintenance worker. He has a terminal that he can do the same thing. He can read the information on a rail car to determine things that may actually be helpful for maybe some predictive maintenance, as an example. And so now we have 3 different types of devices. We have devices that attach to rail cars. We have infrastructure devices that is on land, like again we have here, as well as devices that are going to be held and used by people. So again, of those 1,409 devices that we saw on a previous slide. Maybe this gives a little bit more of a visual to understand that there's a lot going on in the spectrum, and it's not just unlicensed users, it's also licensed users. All right, so now moving back into spectrum, and this seems a little less messy. So 912 to 916, not really a lot going on there. Again, still all of these random ISM devices are omnipresent. The little blue boxes with LN, those are specific frequencies that seem to be part of the commercial devices in use by railroads. So most of them seem to be like, let's say, 913.0, 913.25, 913.5, 913.75. They all seem to be equally spread out, and I know that's for a few reasons. And then we get further up into the 918 spectrum, and we start to see the proposal by NextNav come in for some of their precision navigation services that they're trying to get approval for. And Progeny is another commercial company that we've already talked about. So let's look at something I mentioned a little earlier. There's an organization called the Things Network, or TTN. This is interesting because here we have an example of a commercial company who's using unlicensed frequencies, but the value is, as we see, there's specific frequencies. This makes it very easy for a consumer, and let's call the consumer a farmer. Maybe the farmer wants to have some type of a sensor to know if a gate is open, or to monitor soil acidity or water levels. So there's many different sensors that you can connect to a transceiver, and then you could use the transceiver to talk back to a gateway, and then you could run all sorts of analytics. And so a company like TTN really did something really unique, where they created an entire ecosystem of different vendors using standardized frequencies with other standardized parameters. And as you can see at some of the data at the bottom of the screen, we're talking like big global scale. I made the map just look like it's in the US, but you can see in Europe and Middle East, it's very popular there. So again, 153 countries. TTN has deployments in over 21,000 gateways, which really are things that ingest information to the internet. There's been over 87 million messages sent back and forth across the network, and lots of other great stuff that you can find on social media like YouTube and other repositories on GitHub. So this is actually something that's really cool. And if you're not an amateur radio operator and you do have some interesting use cases, the nice thing with TTN is it's off the shelf, and a lot of the hard work's been done for you. So you don't need to become a software or a hardware expert. If you just have a specific use case, you could easily figure this out and just program it to the appropriate frequency, and everything is ready to go. And by the way, before we move on, TTN in the United States uses this spectrum. In other parts of the world, they're using other spectrum, like the 868 megahertz range. But again, this is a 33 centimeter related presentation, and this is what is authorized for TTN in the United States. Here we have another example of a company called Helium. They actually did something also fairly unique, where they followed what TTN did with having standardized channels. So Helium, you can buy devices that will work on the Helium network, and it actually uses the same frequencies. So there is some level of interoperability, but there's a few major differences of what the value that Helium network offers. So you can look for more information about them on their own website. I think it creates a really interesting dynamic within this highly sought after spectrum. Again, Helium in certain countries will be using different frequencies. In the United States, it's going to be the 902 to 928 on the Things Network related channels. And you can see the map with where their network's been deployed in, roughly like the eastern part of the US as an example. And so they enable lots of different applications like utility metering, disaggregated 5G. And so what I mean by disaggregated, if you're not familiar with that, that means having a cellular network to get access to somewhere, and then doing the last little bit of transport from maybe sensors in the field or some other end user over 900 megahertz. So it combines the two things together. And then really what makes Helium semi-unique is that they also are using this as a way to do some cryptocurrency mining. Again, you can look into details on that. That's way outside the scope of this presentation. But again, here we have two large-scale networks using this unlicensed spectrum. And so it just creates more users on this that we as amateur radio operators need to be mindful of. So finally, we're going to start talking about some ham radio stuff. So just to kind of throw this out, in the United States and Canada today, who also has access to the spectrum, there's 625 repeaters within the amateur radio world. This is where a lot of VHF and UHF communications tend to happen. And so there's only 625. Roughly like 98% of these are all roughly operating the same way. In the past, before there was a real unified band plan, it was a little different. But today, if you were to program these repeaters into a radio, you'd have the output, or meaning the frequency that you listen to, is higher in the band, usually around the 927 megahertz range. And then when you transmit, known as the input, that's in the 902 megahertz band for the most part. So for the most of this 625, almost all of them are using that convention. There's a few things that are not at the lower end of the band, such as some older amateur TV and some other more narrow use cases in the lower part. And I kind of put that screen grab at the left just to kind of give an idea that there are some laggards there, but you'll notice that not all of them are confirmed as being active in that lower part of the spectrum. It's also worth noting that while the majority of 900 megahertz repeaters are analog FM, there's about 6% of them that use some form of digital mode. So this could be P25, NextN, DMR. These are commercial modes with commercial equipment. And so there are people that have repurposed some of that to use in their amateur radio activity. It's not proven that all of those repeaters are actually on the air. I cannot prove that. That's why I depend on a website like Repeater Book. So if you want to look into this for your area, you're more than welcome to run a similar search. And specific to here in New York, I was amazed. There's 22 900 megahertz repeaters spread across all of New York State, which is basically 3.5% of all total 900 megahertz repeaters. And I know specific to where I live, there's one repeater, and then there's a few more to my north. And so if I had some equipment, I could easily go and access those, and hopefully there's other people with radios that I can talk to. And just to kind of further encapsulate this, the United States and Canada are not as special as we'd think. While we are the part of the world that mostly has access to this, our friends in New Zealand also have limited access to this spectrum in their case 915 to 928. Here in the US and Canada we have 902 to 915, but the rest of the world does not use this. For their intensive purposes, most everything is 868. However, in other parts of the world there's no amateur radio allocation in their band, but there's similar devices for consumers that will operate in that spectrum. So again, we're very unique here in the United States as well as Canada and New Zealand for actually having the ability as amateurs to do something within this spectrum. All right, so I promise this is the last super colorful slide. I think this probably has the most ham in the 11 slides so far, and this just kind of wraps up with what we're looking at in terms of spectrum. So again, hopefully this gives you a little bit better idea that there's a blend of a few different things. There's amateurs, which we have access to use the spectrum in a secondary basis. That means that we have to deal with unlicensed device users, which is like a lot of things, as well as licensed users with licensed equipment that's higher power. So again, there's lots going on within this very valuable chunk of spectrum. So if you want to take a look, today, again, is October 1st. This presentation was given last night, September 30th. Latest news as of the date of the presentation and this recording. Things are still being decided about what is going to happen with NextNav's proposal. There were over 1,700 comments, and most of those comments were not just a bunch of amateur radio people complaining that we may lose spectrum. It was others within the spectrum that could potentially be impacted. So if you want to read a little bit more about that, you can do a search for this article. I trust the source on that. You could also do a Google. So I would highly encourage you to kind of stay top of mind as to what actually is going on as it relates to this organization NextNav and their proposal to have a large chunk of spectrum allocated for them and the precision navigation technology that they're looking to bring to market. All right, so like I said, other users of the spectrum. As an amateur, myself and a few friends, specifically Joe NE2Z and Joe N1JTA, we were looking at launching a project quite a few years ago. We were all very savvy, and we're keeping an eye on LoRa, which became a thing really around 2014, started to get that commercial impact around 2016 or so, which we saw in some previous slides. And so we thought, now that there's low-cost development boards, we thought it would be a fun time to experiment with that. So we made some purchases from a company named Adafruit, who's extremely well known, bought some development boards and started to create our own project, and that's what this Has Violet is. So how we came up with that frequency, we wanted something catchy. We used the color codes, red, green, blue, or CSS if you're an HTML web person. So we thought, that's funny. If we do CSS 911250, it gave us this nice shade of violet, and that's really how we came up with violet. And then the word HAS acronym is hardware, antenna, and software. So if you want to look into that, that's, again, its own presentation. But I think it's really worth mentioning here because there were lots of other people around this time doing other cool things using some of these lower priced LoRa chipsets. And over time, some of those projects started to fail. Some of them, the developers lost interest, but many of them found their way and started to look at how they can contribute, which is really the fun thing about being part of open source communities, is that everyone who was doing cool things, like us within Has Violet, another project was Disaster Radio, and we all started to kind of look at something, and what we know today as something called Meshtastic, there's a lot of underlying code that's been utilized within that as probably the most, by far, popular project. And they're actually one of the major reasons why we want to maintain that we have access to this spectrum. They are unlicensed users using Meshtastic, but we as amateurs also need to be mindful about how we can utilize that and contribute. So what else is actually happening in 902? We talked about Meshtastic, we talked about all these other things. Well, here's the funny part. As amateurs, it's taken a while to do some cool stuff. Here's a really fun example that I saw last year. Took this gentleman, call sign W5LUA. It took him 38 years, but he basically bounces his signals off the moon to make contact with other stations back here on planet Earth. And so it's taken him 38 years to make one contact, or at least one contact, in every one of the 50 states. And so with a few others that we see in the article, such as Peter KA6U and Jason N1AV and Brian NX90, they helped him get to the final goal. But the real key here is he's not using low power equipment. We're talking 400 watts into a 5-meter dish. So that's a 15-foot dish. And so we're talking about some large equipment. So there's very few people that are going to take that level of investment and focus to do things like that. And that's, I think, a really fun way to look at this, where when we go from somebody like Al with this amazing accomplishment in the lower part of this band, now we get into something like Meshtastic. You have people today taking these small little devices and maybe taking them on an airplane ride. And in this case, we have physical proof that somebody took a node, suction cupped it to a window, and when you're at altitude, you're going to be able to hear many other Meshtastic nodes, and they will hear you. And so I think this is really innovative, that here we have somebody who's using an 18 milliwatt device and is able to communicate for 100 or so miles using one of these devices, and it's very inexpensive. Again, it's not the same scale as bouncing a signal off the moon 200,000 miles away, but it just shows that there's innovation happening in the non-amateur community who want to do cool things with radio. So hopefully the amateur community can learn from those that are just unlicensed, and vice versa. And this is really what gets us into talking about Meshtastic. So before we do that, though, just to kind of give some other ideas, again, these are not specific to 33 centimeters, but there's other technologies that relate to this that would be of interest to amateurs. And so there's something called automatic packet reporting system. You may have seen some of my previous presentations. Most of this activity uses the same equipment that Meshtastic is based off of, but it is on different spectrum. If you wanted to use a 33 centimeter board instead of 70 centimeter, you can certainly do that. The code is the same, everything is the same, but for the most part, since globally 33 centimeters is not used, the developers behind LoRa APRS for the most part have standardized on a few frequencies. So if you want to check that out and experiment, you can do that. And if you want to be extra special, you can take your learnings of using that and maybe even roll that code on a 33 centimeter board if you'd like to do that in the United States. You have another project here called a Morse Reno. Again, it uses the identical hardware that you can set up a Meshtastic node with, and there's many other consumer-related projects that use these small, inexpensive development boards. And in the case with this Morse Reno, basically it's using a device, allows you to transmit Morse code. So if you wanted to create a 432 or 900 megahertz transceiver to send and receive Morse code using LoRa, chirp spread spectrum, you can do that. But the really cool thing with this project is if you're out of range of other people, you can actually connect this over Wi-Fi to your home network, communicate to other devices over the internet, and be able to talk in Morse code between devices with the internet, creating that air gap in between. So another fun project, and if you're interested in Morse code, this gives it a really fun and clever modern spin.